Last joining us today, a fellow Sun Devil, Rhett Larson, who's a Fulbright Fellow, Associate Professor of Law from the Sandra Day O'Connor College of Law and Senior Sustainability Science at the Julie Ann Wrigley Global Institute of Sustainability. Rhett's going to be talking to you about one of his new awards that he's leading from USAID about water security in the Middle East. And Rhett's great experience in understanding policy, local culture, law, the dynamics of structure and agency and decision making is going to be very influential to that technical and engineering effort that comes to bear. And so Rhett provides great leadership in that.
All right, well, thank you so much to Nate for organizing this and for hosting this event. This has been fascinating already, and hopefully I can keep it going. Just as a disclaimer, I am a lawyer. I am not an engineer, so I'm privileged to be able to work with a lot of engineers on this project, but if you're asking the tough engineering questions for me, I'm going to let you down. So this project that we are working on, and this is a team effort from across a lot of different groups, as I'll talk about, is a USAID funded project to address water security issues in the Middle East. And specifically, we are targeting Lebanon and Jordan right now, and there are hopes that perhaps this will be able to expand further. I'm sure everyone in the room and everyone who is listening is aware of the refugee crisis that that region is experiencing due to armed conflict in Syria. Lebanon and Jordan both experience disproportionately larger problems than other countries. So the largest countries that are absorbing the refugees right now are Turkey, Iraq, Syria, and Jordan. But Syria and Jordan in particular are facing problems. Right now, Syria, there are about 1.5 million Syrian refugees in Lebanon. So about 1 in 4 people in Lebanon right now is a Syrian refugee. There are around, and changes very quickly as you can imagine, there are around 700,000 Syrian refugees in Jordan right now, which is about 1 in 9 people in Jordan are a Syrian refugee. So the challenge of absorbing this population is tremendous, and particularly tremendous for a region that's already experiencing a great deal of water stress. So Jordan is, if you consider the water poverty line to be about 1,000 cubic meters per person per year, so if you fall below 1,000 cubic meters per person per year, you're below the water poverty line. Using that line, Jordan is the second most water poor country in the world, next to Yemen. And Lebanon, while much better off than Jordan, still falls below the water poverty line. So these are both countries that deal with a tremendous amount of both actual and economic water scarcity. So actual water scarcity, a lot of arid regions in both of these countries, and economic water scarcity just costs a lot of money for them to develop their water resources. So the refugee problem aggravates an already difficult challenge that these nations are facing. So what we are going to be doing is, backed by USAID, we have created a team of people to be able to come in and get a distributed approach towards addressing this water challenge in this region. It begins with an organization that I've worked with and am familiar with for their work in India called H2O for Humanity. H2O for Humanity implements these reverse osmosis kiosks. It has a footprint of about 200 square centimeters, so not very large, and it produces about 1,300 liters per hour of treated water that would meet WHO and EPA maximum contaminant level Safe Drinking Water Act standards. Treatment mostly comes from groundwater, so it would be a little bit more difficult to treat surface water sources because of elevated TDS and TSS. But still, this has been successfully implemented in 150 different villages in India and is currently serving about 140,000 people in India. And it is a profitable business model at about 2 cents per liter. So it operates through a microfinancing program where water entrepreneurs in the country can borrow through microfinancing organizations to be able to pay for the kiosk. They operate the kiosk, people come with water containers to buy the purified water, and it becomes a financially self-sufficient, economically sustainable business model for local water entrepreneurs. Now, going back to H2O for Humanity, the role that Arizona State University is playing on the engineering side, and I'm particularly grateful to Nate and his team who is leading the charge on this, is to take this technology and to make it more energy efficient, and the potential of taking it completely off grid. So thanks to the work of the engineering folks here, like Nate at Arizona State University, there's the potential to take this technology that's already being so successfully implemented in India and improve its energy efficiency by about 15 to 30%, and including improving the longevity of its components and lowering the energy costs for the overall infrastructure there by anywhere from 25 to 50%. So the cost savings will be significant, and the durability of the components as well. Now, we've taken this and teamed up with a fantastic company called Greencoat. Greencoat develops BP-free, food-grade quality water storage containers. They're collapsible water storage containers. And in each one of the communities where we will be implementing the H2O for Humanity treatment kiosk, which is a reverse osmosis kiosk combined with disinfection through ultraviolet radiation, we'll also combine this with flat pack technology, which is Greencoat technology of these collapsible storage units. And the collapsible storage units will allow us to get around 70,000 liters of storage for each one of the communities. Now we're adding to that distributed water augmentations. We have distributed water storage through Greencoat, distributed water treatment through H2O for Humanity and ASU's work on the energy side, and then distributed water augmentation through Zero Mass Water. Now Zero Mass, another fantastic company that we're partnering with, who uses a water condensation through solar energy model to augment water supplies. And this has been successfully implemented in many different areas, including a place where I've done quite a bit of work in Ecuador, and it's working out to generate about 100 liters of water per day, so roughly enough water to be able to take care of a family of 4 to augment water supply just through condensation of water in the air, water vapor. Now, we have in-country partners to help us implement this program, to help us locate the best sites and help us find the people who we need to help the most. As you can imagine, site location is a particularly challenging aspect of the project. We want to find places where people aren't already being adequately served with affordable water supplies. We also don't want to cause problems by competing with people who we don't want to drive people out of business. We want to make sure that we're giving people economic opportunities and employment opportunities that they wouldn't have otherwise. And then we're trying to balance the need between addressing water demand issues from Syrian refugee communities while making sure that we're addressing indigenous groups as well within each country. And unfortunately, we've had the Renee Moawad Foundation, who are fantastic partners in Lebanon, and Mercy Corps in Jordan. We work closely with both of these partners to be able to do site selection. So we're going to be rolling out this project beginning in January and over the next 2 years. And the plan is that after 2 years, we should be able to serve 9 different communities in each country, so 18 total communities. With 18 total communities, we'll be able to provide in total somewhere around 44,000 people with clean, renewable, sustainable water that's connected to a financially self-sufficient business enterprise. Now, what do I have to do with any of this? We have a bunch of really smart engineers and fantastic companies who are doing a great job, but my role in this is something I've been interested in a long time, which is the challenge of water rights in the Middle East. Now, the desert is the great incubator of human ingenuity, and it is true in engineering, as we can see where we're from and what the Hohokam were able to do in this part of the world, but it's also true in law. The desert creates great legal innovations, and one of the great legal innovations in history is actually Sharia law. Sharia law is an ancient form of law. It dates back so far that in many ways, many aspects of it predate Islam. And many aspects of Sharia, unsurprisingly for a religion that rose out of the desert, specifically address water rights issues. And under Sharia law, there are 2 concepts of water rights, one called shafa, which is the right of thirst, the right to drink, the other called shirb, which is the right to irrigate. And each country, and indeed each community within a country, will interpret rights of shafa and shirb slightly differently. So for example, between the 2 large sects within Islam, Sunni and Shia, generally speaking, both will divide between public and private waters. Public waters must be provided for free for everyone, and you should not charge for public waters. Private waters are waters that you can sell generally and collect costs. But the line between public and private can be very, very fuzzy and can vary not only between Sunni and Shia, but also between individual communities within those. So for example, a Malakite Sunni community would say that private waters must be given away for free unless the person who's taking the water can afford to pay for it. Then they have to pay what they can afford to pay. Whereas a Hanbalite Sunni might say you can never charge for private waters ever. And you might go into a Shiite community and a 12er Shiite might say, well, you can sell your private waters, but your private water sales are subject to kum, which is a tax that has to go to help the poor. Whereas a 7er Shiite might say, no, 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 as long as you're selling water to people who can afford it and they're buying it back, you're not subject to kum, this tax to support the poor. So what's really important as we implement this project is that we're going into a situation where the level of religious and legal diversity is so complicated, as you have large communities of Shiite refugees who are entering into largely Sunni communities. Their conceptions of water law are very different. So in Lebanon, you have large public sources with a country that has a lot of infrastructure and natural surface water sources. Most of their surface water sources would be considered public. But in Jordan, for example, because of tribes that supported the Hashemite dynasty in World War I, many of these indigenous tribes, including Hoetat tribes, were granted individual rights to their own water sources. Because of that, these rights are considered private rights. And how each one of these individual indigenous tribes will interpret their rights might drive the way that we implement this technology and whether or not you can actually sell the water and get money back. So this great innovation in terms of the law, it creates wonderful opportunities and great chances for us to learn how these ancient communities have managed to share water. For example, in Hoetat communities, they have what's called a kud, and a kud is a person who is a water mediator in water disputes. And you go through what's called a sulha when there's a dispute between different tribes. And the sulha is a ritual forgiveness and a ritual recompense for taking water out of priority as between tribes, because larger tribes have higher priority than smaller tribes. So the complexity of the legal regime in implementing these kind of technologies is really fascinating. So I look forward to talking more with you in the Q&A. Thank you.
Well, one thing that I think of is the challenges with this project is the Hardin principle, something that Garrett Hardin wrote. You know, he's most famous for the tragedy of the commons, which is something everyone who works in water is familiar with. But he also said you can never do just one thing. And I think that's certainly true of any water development project. You can never do just one thing. You can never just increase water quantity. You can never just improve water quality. Stepping in and trying to do anything in water is dropping a stone in the water, and the ripples will run everywhere. And those ripples will be for good and for bad. And many of them you won't be able to predict. And I'm both excited and nervous about the possibility of dropping that stone in the water, knowing that I'm not just going to be doing one thing. I'm going to be hopefully helping thousands and thousands of people in need to be able to get water resources, but I know that I'm going to have to adapt. I'm going to have to change the way that I think, and we're all going to have a project that's flexible to be able to meet the needs and the sort of cultural nuances in which the project's going to be implemented.